Good day. So in this video tutorial, we are going to talk about the trigonometric functions of an angle. So our session objectives are as follows. Find the values of the 6 trigonometric functions of any angles and find the 6 trigonometric ratios of an angle whose one trigonometric ratio is given. Right. So what is trigonometric functions? So this is defined as the connection between the legs and corresponding angles of a right triangle. So when we say trigonometric functions, this is just the same as getting the trigonometric ratios of a particular angle. Now, let's talk about the trigonometric ratios. Let's go back to our idea of the trigonometric ratios. So, let's always remember the SOHCAHTOA to remember the connections between the legs or the parts of a right triangle. Okay, so if we have sine theta, so that is opposite, okay, over our hypotenuse. If we have cosine theta, so that will be equal to adjacent over hypotenuse. And if we have tangent theta, so that will be opposite over adjacent. So following the SOHCAHTOA. And we also have our reciprocal trigonometric ratios. So we have cosecant theta. So just get the reciprocal of this. So that will be hypotenuse over opposite. And we have secant theta. So that will be hypotenuse over adjacent. And we have cotangent theta equals adjacent over opposite. Alright, so always remember these trigonometric ratios. Now, we have here some illustrative examples. So for the first one, find the other trigonometric functions of the acute angle, given that cosine theta is equal to 2 over 5, and find the value of theta. Now, in this particular example, we are only given with one trigonometric ratio, and we are asked to find the other trigonometric functions. So we need to find the sine, the tangent, cosecant, secant, and then the cotangent. But how are we going to do that? The first thing that we are going to do is to always remember the ratio. So that is cosine theta equals 2 over 5. And we say that cosine is actually adjacent over hypotenuse. So the numerator here will be our adjacent side, and our 5 here will be our hypotenuse. So let's try to draw the right triangle. Okay, so we have here our right triangle, and we will position the theta here. Okay, and then we're going to locate the position with respect to the theta. So 2 is our adjacent. So here is 2, and then 5 is our hypotenuse. So here is 5. Okay, so in solving for this, we need to always remember that there is a missing side, and we can solve for this missing side using our Pythagorean theorem. So in this case, we are looking for the altitude A, and the formula is A is equal to the square root of C squared minus B squared. Alright, so let's now try to solve. So that will be the square root of 5 squared minus 2 squared. Okay, so that is equal to the square root of 5 squared is 25 minus 2 squared is equal to 4 equals, so that will be 25 minus 4 is the square root of 21. So since we are asked to express our answers as radicals in simplest form, the square root of 21 is already our answer. So this will be our altitude. So the square root of 21. So we are now complete with all the measurements of the sides. So we're now ready to get the trigonometric functions. Okay, so we will begin with our sine theta. That will be equal to, so that's so the square root of 21 over 5. So we are already given with cosine theta. So that is cosine theta is equal to 2 over 5. And then we have our tangent theta is equal to, so that's TOA. Okay, so opposite over adjacent. So that is the square root of 21 over 2. Okay, then we get the reciprocal. So this will be cosecant theta is equal to, so that is 5 over the square root of 21. But we need to express this in simplest form. So this will be equal to 5 and the square root of 21 over 21. Okay, next. So we have secant theta. So that will be equal to, get the reciprocal of this. So that would be 5 over 2. And the next, we have our cotangent theta. So that will be equal to 2 over the square root of 21. Next, simplify. So this will result to 2 and the square root of 21 over 21. So we have now all the 6 trigonometric functions. Okay, so we are also asked to find the value of theta. So let's now solve for the value of theta. So theta is just equal to, so we just choose 1. Okay, so we get the inverse sign. So that would be inverse sign, okay, of this. So that would be the square root of 21 over 5. And then just input this in your calculator. So theta will be equal to, so that's 66.42 degrees. So round off to 2 decimal places. Okay, and we're done with this first example. Okay, we found out already all of the trigonometric functions as well as our angle. Okay, so let's just review about the procedure. So the first thing to consider is to get the ratio and then identify the positions based on our theta. Okay, so and then we need to draw the figure so that we can represent the ratio, solve for the missing side, and if the sides are already complete, then we can get already the trigonometric functions. And eventually we can solve for the theta or the angle. Alright, so let's proceed to our next example. Okay, another. Find the other trigonometric functions of the acute angle given that tangent theta is equal to the square root of 3 over 3 and also find the value of theta. Okay, now in this case, we are provided with tangent. Okay, so let's write it first. So tangent theta is equal to the square root of 3 over 3. So that's TOA. Okay, so this is our opposite and this is our adjacent. Okay, now let's again draw the right triangle with the theta, okay, positioned here. Alright, so that's TOA, opposite. So we have the square root of 3, opposite. And then next adjacent, we have 3. So we are actually solving for the hypotenuse. And the formula that we're going to use is C is equal to the square root of A squared plus B squared. So that would be equal to the square root of our A is square root of 3 squared plus 3 squared. Alright, next simplify. So that will be equal to, this will be the square root of 3 times the square root of 3 is just equal to the square root of 9, or square root of 9 is 3. Okay, or simply we can cancel this out. So 3 plus 3 squared is 9. Alright, so that would be equal to the square root of 12. So, further simplifying, the square root of 12 can be simplified as 2 and the square root of 3. Okay, so we have the hypotenuse 2 and the square root of 3. Okay, so the sides are now complete. We are now ready to get the trigonometric functions. So let's start with sine theta. Okay, so sine theta is okay, so that's the square root of 3 over 2 and the square root of 3. So you simplify this. Okay, so that's cancelled out. So that will be 1/2. Okay, and then we have cosine theta, okay, is equal to, so that would be adjacent over hypotenuse. So 2 and the square root of 3. So further simplifying, just input in your calculator. So this will be the square root of 3 over 2. And we have our tangent, of course, because it's already given. So tangent theta is equal to the square root of 3 over 3. Okay, so it's already given. Let's now get the reciprocal. Okay, so this will be cosecant theta equals 2 and the square root of 3 over the square root of 3. So cancel here. That will be equal to 2. Or just get the reciprocal of this. So 2 over 1 is just equal to 2. Okay, and then secant theta will be equal to, that's 2 over the square root of 3. Or further simplifying, we have 2 and the square root of 3 over 3. Okay, so we now get the cotangent. So cotangent theta is equal to, so that will be 3 over the square root of 3. So further simplifying, we get the square root of 3. Okay, so we're now ready to get the value of our theta. So we used again inverse sine and get the fraction for the sine. So that is 1 over 2. And type this in your calculator. So inverse sine of 1/2. So this will be exactly 30 degrees. Okay, so that's it. So that's how we find the other trigonometric functions of the angle given only one ratio.